Hey everybody, I wanted to do one of the classic physics demos for you, which is to drop a basketball with a tennis ball perched on top of it. It's fairly impressive when it goes right. I bet you did not expect that tennis ball to have quite that much velocity. And the reason it does is basically because the basketball hits the ground, it changes direction while the tennis ball is still moving downwards. So it's almost like a bug going at like 3 miles an hour, hitting the windshield of a car and suddenly ricocheting back at 45 miles an hour. Now, in the case of the bug, that's a totally inelastic collision, so you don't see the bug go shooting off the windshield. In the case of the tennis ball, it's a partially inelastic collision, so some of that kinetic energy that was lost when the bug hit is actually retained in the tennis ball, and it leaves with a pretty large velocity. Now, we can model this and do math to figure out what velocity and how high the tennis ball would go, assuming it goes straight up, if we assume it's an elastic collision. It's obviously not a great assumption. If we watch the basketball, it loses energy on each bounce. However, I think going through the math behind it is a good exercise to give us at least a ballpark estimate of how high that tennis ball would go.